In this tutorial, we are going to talk about the basics of Pygame. We are not going to work on any kind of presentable project, we're just going to talk about how Pygame works on a basic level, and we're going to draw some basic stuff. Nothing fancy, but if you are new to Pygame, this should be a really good way to get started. There are two concepts that you really need to get anything done in Pygame. The first one is surfaces, and the second one is the game loop. Surfaces are the easier part. A surface is basically just a layer you put stuff on. This could be an image or it could be a solid color. It doesn't really matter. You could also draw other things on it, but by itself, it's just an empty layer that you put stuff on. And in Pygame, we have two different kinds of layer. The first one is called the display surface, and then we have a regular surface. The only difference is that the display surface is going to be shown to the user, and all the other surfaces are only shown if they are put on the display surface. But besides that, they are basically identical. And we're going to create one in just a second. But before that, we have to talk about something else as well, and that's the game loop. And this is basically how any kind of video game works. Essentially, we are going to run a loop, and on every cycle of this loop, we are going to update our game. So let's say we have an image on our screen and we want to move it to the right. On every cycle of our loop, we're going to move it by 5 pixels to the right. And since this is going to happen multiple times, the image is going to move very slowly to the right. And that's basically it. Obviously, you can add lots more stuff to this to make an actual game and create presentable animations. But by itself, this isn't a difficult concept. So let's actually create a very basic outline for Pygame. The very first thing we need is to import Pygame. This part should be fairly obvious. If you want to use Pygame, you need to import it. Obviously, before you can use it, you need to install it, which you can do in the console or on the PowerShell. And besides Pygame, we also need to import sys, which gives us access to some system commands. The only one we need is to shut down the program at the end when we're finished with the game. And once we have that, we need to create some general setup. So let me add a comment here. And the very first thing we need is pygame.init. It actually does quite a few specific things, none of which you have to worry about in detail for this tutorial. And the other thing we need is a clock. And we get this one with pygame.time.clock. And be careful about capitalizing the first letter of clock, that one's important. And this one basically tracks time on how fast our game is running. And we're going to use this later to control how fast our game is going to run. And that's all we need for the general setup. Next one, we need to create the display surface. Create the display surface. And to create a display surface, we have to put it first into a variable. I usually call my screen, but it doesn't really matter what you call it. And to create the display surface, we need pygame.display.setMode. And the only argument you really need is a tuple with the width and the height of the screen. In my case, I'm just going to put 800 times 800, with this one being the width and this one being the height of the screen. And now we have our basic surface. With that one done, we can come to the actual game loop. And this one is pretty much just a while loop that runs perpetually. So while true just means that this is going to run unless we stop it from the inside. If we don't stop it from the inside, it is going to run forever. And the only thing we really need to do in here is to check for event in pygame.event.get. And let me finish typing this first, and then I'm going to explain what all of this means. .pygame.quit pygame.quit and sys.exit. So all that these couple of lines do is enable us to close the program once we're done with it. So basically, on every cycle of this while loop, we look for some kind of event. And events in Pygame are literally just inputs from the user. This could be pressing a mouse button or moving the mouse, or it could be pressing a keyboard button, could be lots of different. And the only one we are looking for is pygame.quit, which is pressing the X button at the top left of the screen. And if that's the case, we want to shut down the game. And pygame.quit is the opposite of pygame.init. It just uninitiates the entire program. And then we use sys.exit to reliably close down the game. It is not strictly needed, but it is a safer way to close the game. So all of this just enables us to close the program once we're done with it. And if we didn't do this, we would have to go to the task manager to close the program. There's two more things we need, and the first one is Pygame.display.flip. And all that this one does is it takes anything that was drawn inside this while loop and it draws it. So then the user can actually see it. So how the game is going to run later on is that in this while loop, we are going to draw lots of stuff. And this is going to happen on every single cycle of this loop. And at the end of each loop, with this line, we just draw whatever was printed in this cycle of the loop. And there's one more line we need, and it is clock.tick, and then we need our frame rate. In our case, I'm going to go for 60 frames per second. Which basically just means that we're going to run this while loop 60 times per second. So about every 17 milliseconds. And if we are running this, we should be getting a plain black screen that is 800 by 800 pixels high and wide. And controlling the frame rate with this line here is going to get really important. It is not going to matter for our tutorial, but for more complex games it is going to become really important. The main reason for that is that the speed of your animations is determined by the speed of how fast or how often you call this while loop. So think of if this is something like 10 and you move an image 10 pixels to the right. If you do this 10 times per second, it moves at a fairly slow speed. If you do it, let's say something like 1000 times, it is going to move much faster. And if you didn't specify this line, your computer would just run the game as fast as it could, which in most computers would be probably something like 10,000 times per second, which might destroy some animations because they just play way too fast. And it would also make the game inconsistent, because some people with a fast computer might have a different experience from people with a very slow computer. So in our case, we just keep it at 60, and this is usually a pretty good way to go forward. And alright, now we have our very basic setup that we can display a black screen. So what you can see right here is the display surface. And this is going to be drawn every 60 milliseconds, so 60 times a second. But obviously we can't really see anything, so let's add something to it. The first thing I want to do is just fill this entire thing with a color. And this can be done by targeting this screen variable. We need screen, and then we just need to fill it. And now we need to give an argument, and the simplest way to add colors in Pygame is with an RGB tuple. All that means is that you need 3 numbers. Let me go 0, 0, and 0. The first one, actually I could just write RGB, that explains it better. So we are talking about the amount of red we have, then the amount of green we have, and the amount of blue we have. And then we mix all 3 together, and we get a result. And this goes from 0 to 255, with 0 being the absence of the color and 255 being the full color. So if we did something like 255, 0, and 0, we would have full red, no green, and no blue. So if I run the game now, we should be having a red background. And there we go. And in my case, I just want a white background, so I add 255, 255, 255. So we have full colors, and this gives us a white background. And that's the easiest way to go on about it. With that one done, now we have a display surface. But that's still quite basic, so let's add a second surface to it. And I am just going to call it second surface. And we can create surfaces in a couple of ways. The easiest one is with pygame.surface, and we need to pass in a list with the width and the height, kinda like we have done here. And let's say this surface should be 100 times 200 pixels. If I run the game now, you are not going to be able to see it. The reason for that is that Pygame only displays the display surface. If you have a regular surface, it is not going to be shown unless you specifically put it on the main display surface, which we can do quite easily. And all we need for that is screen.split, and we need this surface, and then we need to add the coordinates where we want to put it. Let's say in my case, I want to put it at 0 and let's say 50. So this is the x coordinate and this is the y coordinate. And there we go. We have a new surface that is 100 pixels wide and 200 pixels high. And we're going to put it at coordinates 0 and 50. That we do have a coordinate system to place stuff on. But this coordinate system is different from what you have learned in high school. The main difference is that the origin point is not in the bottom left, but in the top left. And if you want to go down, you have to increase y, which can get quite confusing quite often, but you will get used to it quite fast. But that being done, now we have a blank surface. And since we didn't specify any color, it is just going to be black. But we can add a fill color to it, just like we added a color to the display surface. So I need second surface dot fill, and let's give it, let's say 0, 0 and 255. So this should be a blue color. And there we go, now it's blue. So this is already covering how to add different surfaces. But right now, the surface we have is just a plain color, which gets kinda boring. So let's import a picture. And in this project, in the same folder where I have the script, I also have a file that I have called kitten, which is just a picture of a cat. So I'm gonna call the next variable kitten. And to load a picture into Pygame, we need pygame.image.load. And the only argument we need is the name of the file, which in my case is kitten.png. And when you import an image into Pygame, this image is going to put on its own surface. So when we run this, we are not going to be able to see this. And indeed, we cannot see it. But again, we can fix this quite easily. All we need is screen.split, and this time we need kitten, and we need to give it a coordinate. Let's say this time I'm going to give it 100 and 200. And if I run it now, we should be able to see it. And there we go, we can see the image now. And basically what we have done with both of these, we created a surface with this one and with this one. And for both of these, we have to put them specifically on the main display surface. So that should cover the basics on how to add visual material to the screen. But here's the problem. Neither of these surfaces could be moved by itself right now, because we cannot move surfaces in Pygame. Instead, what we need is called a rect, which is short for rectangle. And all that really does is that it takes a surface and draws a rectangle around it. And then you have lots of points where you can grab this rectangle and move it in specific places. And here's a picture of all the attributes you can grab from a rectangle. Probably the easiest one is the center, which is a tuple that contains the x and the y coordinate. Besides that, you have left, top, right and bottom, with left and right just being the x coordinate and bottom and top just being the y coordinate. And then we have 8 more variables that are called mid-left, mid-top, mid-right, mid-bottom. And we have bottom left, bottom right, and top left. And each of these are tuples that display the specific coordinate of this point in x and y. And finally, we have a height and the width, each of which is denoted with h and w. And all they do is give you the height and the width of the rectangle. So there are quite a few coordinates that you can use to influence the rectangle. So I create a new variable that I'm going to call kitten_rect. And all we need is kitten.getRect. So what it does is it takes this image and it draws a rectangle around it. And this rectangle we could display quite easily. So we could use the print function and type kitten_rect.w, for example, and this would give us the width of our kitten image. If I run it now, we can see it's 375 pixels wide. And if we put this with h, we would get the height, so it's 250 pixels high. And we could also look at the center of it, and we would know that the center, so this point here, is 187 and 125 points. That being said, there's one slightly confusing thing. And let me just illustrate this by typing top left. Because this one is going to be 0, 0, which is this point here. But we know that the origin point would be all the way in the top left. So these coordinates seem wrong, but they are not. The issue here is that getRect is relative to the image. So this image has an origin point in the top left. And this is what getRect gets you when it uses top left. So the rect is not relative to the display surface, it is relative to the image that we have applied it to, which can get really confusing, and we can talk about how to solve this issue in another tutorial. Alright, and for the final part, let's move this picture and see how we can do that. And this is generally quite easy, but there's a little bit of a pitfall. And let me explain what that means. So we couldn't move an image, instead we would have to move the rectangle. But if we just move the rectangle, nothing would happen. And let me demonstrate this. So let's take kitten rect dot right plus equal 5. And this means that we take the right point of the rectangle and move it 5 pixels on every cycle of the loop. And how you move rectangles is you basically take one point of them and move it. And if you move one point, you move all of them. They always stay relative to each other. But if I run the code now, nothing happens. The picture doesn't move. But if I print the rectangle's positions, so print kitten rect dot right. If I move this, and we can see this is increasing. So we get a higher number on each cycle. So what basically happens is that the rectangle moves, but the image does not move. And this is an important thing to understand. That if we take getRect, it only gives us a rectangle around it. It does not mean that the rectangle and the image are closely connected. So far, we only have an image and we get the rectangle around it. Nothing more, nothing less. So we have to actively connect the two, which is actually quite easy to do. And the way we are doing that, let me get rid of these two, is that when we blit the surface, so when we blit the kitten, instead of putting it on one position, we put it on the position of a rectangle. So kitten rect. And now if we move this rectangle, then this kitten would always be in the position of the rectangle. But there's another problem now, that if we use this approach, then we lose our access to the position where we first placed the rectangle. But that's not an actual problem, because when we get the rectangle, we can place a specific position where we want the rectangle to be. So when I type in here, top left, and I need to add a list, and I think it was 100 and 200 that I used before. And what this means is that when we take the rectangle of this image, we place the rectangle on these positions, or we place the top left on these positions. And then later on, when we actually place the image, we take the image and put it on these positions. So this should get basically the same result, yeah. But now, when we move the rectangle, so kitten rect dot right plus equals 5, now this should be working. And there we go, now we have a moving image. And you could move this thing around as much as you want. And that is pretty much the basics of moving anything around. But generally, this kind of approach isn't ideal because you need lots of lines of code that is very difficult to maintain. And as a consequence, it is much better to use sprites when you want to move stuff, which I've talked about in its own tutorial. So check that one out to get more information. But otherwise, I hope it was helpful and I see you around.